So I've got a new recording going, and I'm happy to introduce Ryan Toot. Ryan is a former graduate student here. Ryan, it's good to see you in your new role. Ryan is working with the Northern Institute of Applied Climate Science, and he's here to talk to us about some of the tools and information that NIAX has developed related to or to help forest managers make good management decisions in the face of a changing climate. So Ryan Toot, the screen is yours.
Yep. Thanks, Eli, for inviting NIAX to present today, and thanks everybody for being here. I'm really excited to share some of this information with you. As Eli mentioned, I'm Ryan Toot, and I'm a climate change specialist with the Northern Institute of Applied Climate Science, also known as NIAX. This is a detail, so I'm going back to a role as a watershed forestry specialist starting in January, but I'm excited to talk with you all about this today. So a little bit about NIAX. They are a multi-institutional collaborative that's chartered by the USDA Forest Service, universities, and nonprofit and tribal conservation organizations. The Forest Service does provide primary support for this organization, but everybody in the organization provides partnership and support and perspective. We provide practical information and resources, as well as technical assistance related to forest and climate change for everybody. And our work really tends to center on focus on helping natural resources managers make climate-informed decisions. So this is really kind of what we're all about. A lot of the work that NIAX does falls under this climate change response framework that has been developed, which is made up of 4 components, and that's partnerships. Again, we work with everybody to incorporate climate change adaptation into land management. Vulnerability assessments, of which NIAX has completed quite a number, and we'll go over those in a little bit more detail later. Forest adaptation resources and adaptation demonstrations. And the outline for today's presentation is going to follow these components pretty closely, these last 3. We'll talk about some of the broader climate impacts we expect in the Lake States, talk about some of the vulnerabilities of those pine-dominated systems, and then about the adaptation resources that NIAX provides, and then talk about one adaptation demonstration. So most of us are aware that climate is changing, and climate definition is weather patterns most of the time over about 20 or 30 years, so that we can kind of look beyond some of that interannual and annual variability that we see in weather. Of course, year to year weather is pretty different, but if you look over 30 years, you can get a better picture for how things are changing. And climate really differs by season and by location. And so the maps that I'm going to kind of take you through today break some of that down a little bit. We're moving through it fairly quickly, so we're not going to see all the nuance there, but it'll hopefully give you a good idea of how climate has been changing and how climate will change in the future. And globally, our average annual temperature is about 2 degrees Fahrenheit higher than it was in 1880. But as we can see here in the Lake States, we have very significant warming in the winter and warming in the summer as well, but a little bit less so. So the map on the left-hand side here, DJF, that's December, January, and February, and this is average temperature for those months. So those are our winter months. And you can see it varies a little bit across the Lake States, but we see between 3 and 6 degrees warming in the winter, and between 0 and 2 degrees warming in the summer. So on the right-hand side, we have JJA, and that is June, July, August. And this is for about a 70-year period ending quite recently. Of course, precipitation is also changing. And again, it changes differentially by season. Winters tend to be much wetter in the past about 70 years. You can see that's about 20% increase in precipitation over much of the Lake States. However, summer is much more variable. We see in some areas that it's quite a bit drier, up to 15%, like in the Western UP. But in some areas, like in southern Wisconsin, it is wetter in the summer as well. There are fewer significant trends on the map on the right-hand side that's showing the summertime precipitation. And this is just kind of getting to that point as well, that precipitation is a lot more variable over this time period, the 70-year time period in the recent past. So we also want to talk a little bit about how we expect climate to change in the future. Of course, trees are long-lived species, and as we manage these, we want to know that they will continue the trees that we are managing now will continue to be successful in 50 or even 100 years. So to lay a little bit of groundwork for that, it's helpful to know that climate is projected using something called a general circulation model, or a GCM for short. And there are a number of models out there. They all have slightly different results. So a good way to take a look at what these models are really saying is to either look at an average of these models, or you can use them to kind of bracket, look at hot models and look at cold models to kind of look at the range of projections. There are also a range of potential greenhouse gas emissions scenarios, right? So the climate is warming in part and largely because of the greenhouse gases that we are emitting. And so looking at different emission scenarios as we go through this century is really important. And we can use these to bracket expected future conditions as well. So these are called representative concentration pathways, these greenhouse gas emission scenarios. And you can see on the screen here that they result in varying degrees of warming throughout the century. And for bracketing our look today at what projections are, we're going to use RCP 8.5, which is a higher emissions scenario where emissions peak at the end of the century. And our lower bracket scenario with lower greenhouse gas emissions that we'll look at is RCP 4.5, which assumes that emissions peak sometime around 2045 and decline thereafter. So using these two RCPs, we can kind of get a good range of potential future conditions. So this time, we're looking at maps of projected temperatures towards the end of the century. Again, you can see here that we're looking at a 20-year time period, essentially over this 21st century. And this is change in annual temperature. So please remember that wintertime temperatures are warming faster than summertime temperatures, and actually minimum temperatures are also warming more than average temperatures if we're considering monthly temperatures. So those nighttime temperatures are warming faster. And as you can see in our lower change scenario, we expect an increase of about 6 to 7 degrees Fahrenheit over this region. And on the right-hand side, with a higher emission scenario, we see between 11 and 13 degrees Fahrenheit increase in temperatures. Now, summer minimum temperatures, which I understand are important for red pine specifically, are also expected to increase, of course. Again, minimum temperatures are warming faster than maximum temperatures, so I just wanted to show you guys this quickly as well. And we can see that minimum temperatures in that lower emission scenario rising between 6 and 7 degrees in most areas over this century, and in the higher emission scenario rising between 11 and 13 degrees Fahrenheit. So precipitation, of course, is also changing. And again, we're seeing wetter trends in the winter and in the spring especially. But if we look at annual change, we see increases of between 5% and 10% for the lower emission scenario, and between 5 and 15% for the higher emission scenario over this century. So we talked a lot now about precipitation, and we've talked about temperature. And precipitation in the summertime is, as I mentioned, is a little bit more variable, and over this century might remain somewhat constant for our lake states. However, because temperatures are rising, vapor pressure deficit is expected to increase. And if you think about our cold winter air, we know that cold winter air is fairly dry. Colder air can hold less moisture than warmer air. So as those temperatures increase, evaporation and transpiration will also increase, which results in drier soils and more drought stress on the plants. So even though we're getting the same number of, or potentially similar numbers of inches of precipitation over the lake states throughout the growing season, or at least throughout later in the growing season, vapor pressure deficit is going to be higher, and there will be more drought stress on our plants, especially as the growing season wears on. One thing that I didn't mention when we talked about precipitation as well is more precipitation is coming in more extreme or heavy events. So there's longer amounts of time potentially between precipitation events during this growing season. And because of the vapor pressure deficit increase that I just talked about, and because of this trend of heavier events, we are seeing projections of more extreme drought throughout the century. You can see, with the higher emission scenario, that's nearly 70% the amount of extreme drought later in the century, 70% more. So of course, all these climate impacts really do impact our forest. Warmer temperatures result in a longer growing season. The increased amount of CO2 in the atmosphere can have some fertilization effect on plants. So this could increase productivity to some degree. Of course, productivity is always limited by nutrients or moisture or other demands that plants have. There's also an increased drought risk, which I mentioned. Extreme weather events, of course, extreme precipitation events cause flooding, and a lot of times those extreme events come with high winds as well, which cause disturbances in our forests. There's going to be less frozen ground, which impacts the way that we're able to operate in our forests. Of course, logging and harvesting in the North Woods here relies a lot on frozen ground on sensitive soils and in wet areas. There's an increased fire risk, which is related to that increased drought. We expect species range shifts, notably the boreal species here in the lake states, as well as the broadleaf species, both creeping northward. And there are, in general, going to be increased stressors. And that's because climate change really is a threat multiplier. There are many stressors that currently exist in our forests already, and the impacts of climate change really will exacerbate many of those threats. One example here is diplodia shoot blight in red pine. Outbreaks often occur after several years of drought. Well, drought might be increasing because of climate change, and in addition, those outbreaks can be sort of precipitated by hailstorms or other damage to our forests, and extreme events might increase instances of those damaging events as well. So the stress and the impacts from diplodia on our red pine stands could increase. That's just one example of how climate change multiplies existing threats. So I'm going to take a little step back here, and we're going to talk about vulnerability a little bit more broadly. So vulnerability is the susceptibility of a system to adverse effects, and it is comprised both of climate impacts and of adaptive capacity of these systems. So NIAX has completed a number of vulnerability assessments throughout the lake states. I have sort of the geographic breakdowns of those vulnerability assessments on the slide here. And those were written in 2014 for the lake states. And there are also more recent climate change field guides for northern Minnesota, northern Wisconsin, and for southern Wisconsin as well. And so a lot of the information that I'm presenting here today is is within these vulnerability assessments in the field guides. So these are really great resources to go to for more information about, climate change in pine ecosystems, but also in other ecosystems throughout the Lake States. They're really written for natural resources professionals, and they cover background on the contemporary landscape, climate change, impacts to forest ecosystems, and they evaluate key tree and forest ecosystems vulnerabilities to climate change. They do not make recommendations or assess vulnerability to changes in management, land use, or policy. So they're really focused on that climate piece. And these vulnerability assessments are informed by a number of things, but a couple of those things are modeling approaches. And one of those modeling approaches is the Climate Change Tree Atlas, which maybe you're familiar with. Climate Change Tree Atlas models suitable habitat for 125 tree species in the eastern US, based on climate, soils, and site variables. These models don't include management or disturbance. Version 4 is out now, so you might have, maybe you're familiar with the Tree Atlas of the past. I urge you to take a look at it now. There are some new things associated with it and updated projections. So some projections are a little bit different. You can now get results for geographic areas of varying types, including states, eco-map sections, national forests, or single degree by single degree grid cells. That's the finest grain that you can get with those automatically generated summaries. There's also new information about colonization, and there is a lot of information about how to interpret the models, how the models work. There's tutorials, videos, frequently asked questions on that site. So I urge you to go take a look. And we will be looking at some of the version 4 Atlas results during later in today's presentation, and we can walk through interpreting some of those for our pine systems. So one of the new things that the Climate Change Tree Atlas version 4 has is addressing capability for different tree species, and capability is the overall ability to tolerate future conditions. And it's really a rating of the species' ability to cope or persist with climate change based on suitable habitat change, which is the modeling that the Tree Atlas does, as well as literature review and expert opinion. And it's also modified by current abundance based on the FIA data. So on the screen right now, I have the capability from the Climate Change Tree Atlas in these 3 geographic areas in our Lake States. And I have the pine species kind of boxed in red so that you can see them. And you'll see it varies a little bit across the different geographic areas. But largely it's fairly similar. And we'll kind of address these all collectively today as we walk through some of the vulnerabilities. So we see that, red pine has fair capability in Minnesota and Michigan. It's poor in Wisconsin. Jack pine has fair capability in Minnesota and Wisconsin. It's good in Michigan. And white pine has fair capability in Wisconsin and Michigan, and it's good in Minnesota. And if you look a little closer, you'll see that northern red oak, northern pin oak, and red maple all have good capability. And these are some species that, maybe they're associated with the stands already, or maybe they're good candidates for some of the similar sites that pine species occupy currently. So we'll be talking about red pine, jack pine, and white pine all a little bit separately. There's a lot of similarities between some of the sites that these pine species occupy, but we'll walk through them separately to kind of get as fine a grain information as we can, knowing that in many cases these species might be coexisting, especially red pine and white pine. And these are all also fire dependent systems, which will come up as we step through the vulnerabilities of each of these systems. So to start with, we can talk about red pine, and I want to go over a few of the system characteristics that are important to red pine. You'll notice on screen right now the characteristics that are important for red pine as we think about climate change. You also notice that it mentions Wisconsin. This graphic and the graphics that you'll see in the coming slides are pulled from the Wisconsin Climate Change Field Guide. And we'll kind of be using that to talk about the lake states at large and these pine systems. So pine stands oftentimes are plantations. Even the natural stands are fairly monotypic, or if they're plantations, they might be single species plantations. Red pine is shade intolerant. Management, is typically clear cutting or cutting large gaps and planting red pine for regeneration. It occurs on a range of soil types, although many of these plantations, especially Minnesota and Wisconsin and Michigan, are in sandier soils, but it can occur on more mesic soils. Again, it's a fire adapted species, and it's limited by warm nights at the southern extent of its range. I don't know a whole lot about that. I would love to know more about that. I'm not going to type a question into the Slido right now, but I would love to see discussion about that, because that's something that I've come across a number of times and don't know a whole lot about. So I'd be curious to hear what folks know about that. So looking at tree atlas results for red pine, we see that so we'll walk through this. This is the first time we're looking at tree atlas results together. The colors that we see are importance values, and the darker blue is higher importance value. As we get lighter and into the greens and yellows, that's lower importance values. Importance values are based on basal area and stems per acre. And we can see with the current FIA data, that's actual data from the Forest Inventory and Analysis, that where red pine exists, it tends to be a very important species, but it doesn't, cover the entire landscape of the Northwoods. It's common, and where it exists, it's very important. And as we look to the future with these different emission scenarios, 4.5 and 8.5 at the end of the century, essentially what we're seeing is not a whole lot of suitable habitat difference. We don't really see range contraction here. We do see lower, maximum importance values, and we see some importance outside of the sites where it currently exists. But overall, this really isn't a whole lot of suitable habitat change. What this might indicate is that where red pine is now, there might be sites where it's not now that could be suitable in the future, and some sites where it is now might be a little bit less suitable in the future, but not significant change. And we'll actually see that with a number of these pine species in the tree atlas results. That's not to say that climate is not going to impact red pine. There are a number of ways that climate could impact red pine, and they're on screen now. And some of these are going to be similar across the pine systems. One of those is deer populations are expected to increase with warmer winters, and red pine is sometimes browsed by deer. Dry summers and droughts might reduce survival of the planted seedlings. Red pine is fairly drought tolerant, especially the mature trees, but this could impact some of the planted seedlings. There are a number of diseases and pests that impact red pine. I gave one example of those. Those could become more damaging to red pine in the future. And although red pine is drought tolerant, on some of those more marginal, really dry sites, they could be more favorable for jack pine or northern pin oak in the future. And of course, there's a note there too about ongoing fire suppression favoring broadleaf species that are not fire adapted. There are some adaptive traits of red pine. Again, it tolerates drought well. It is fire adapted. And it might be able to expand to some currently more mesic sites that might be occupied by aspen and birch or oak or northern hardwoods now as the climate gets drier. But red pine has low diversity typically. Again, these are monotypic stands, oftentimes single age stands. And so there's low structural and species diversity, which reduces the adaptive capacity. It also has low genetic diversity as a species, which reduces its adaptive capacity. And so overall, red pine has a moderately high vulnerability to climate change. Jack pine, again, is a fire-dependent species, occurring on probably even more drought-tolerant sites or more droughty sites than red pine, probably more drought-tolerant than red pine is. And it also tolerates cold quite well. So looking at the tree atlas results for jack pine, we see kind of a similar effect in the future as we saw with red pine. You notice that maybe jack pine is a little bit less present on the landscape than red pine, but suitable habitat really is not projected to change very much in the future. Again, we see slightly lower importance values and perhaps existing on more places across the landscape based on those results. But again, climate change will impact jack pine. Some of the sites where it is now might become too hot and too dry for jack pine. They might actually shift to barrens. It might be difficult to keep trees on these sites or keep them forested. Jack pine is also impacted by diseases and forest pests that might become more damaging. But again, jack pine, it is drought tolerant, so droughts, jack pine may be able to continue to exist on the sites where it is now in the future, even though it will be more droughty. Again, jack pine could colonize areas where it is not currently, that might be currently occupied by red pine or white pine. And it's fire adapted, so increased fire could be beneficial for this species. But again, jack pine has somewhat low species diversity. Jack pine is another species that is fairly monotypic. So it oftentimes is the single species in a stand. So overall, jack pine has moderate vulnerability to climate change. White pine is a little bit different than the other two. It occupies a more diverse range of sites, in Minnesota, as well as being a part of those fire-dependent native plant communities. It's also a part of the central wet mesic hardwood communities and the northern wet mesic hardwood boreal conifer systems. So it's more competitive on drier dry mesic sites, but it really does exist on a range of sites. It's also fire adapted. So tree species results, or tree atlas results for eastern white pine. In the lower emission scenario, we see kind of a similar effect as we did with the other pine species. Again, slightly lower maximum importance values, but importance values on some importance on more sites across the landscape, more areas across the landscape. But as we look to the higher emission scenario, we do see some decrease in those importance values. The blue that exists here is no longer blue, and we see some contraction in these darker colors. So there could be some suitable habitat loss in the higher emission scenario at the end of the century. But overall, not a huge change.
Hey, Ryan, just going to interrupt for a quick time check. You've got about 9 minutes left. Perfect.
Thank you. So for eastern white pine, you can see some of the climate change impacts that are going to impact white pine on the screen there. Again, drought could favor some of the more drought tolerant species impacted by deer and diseases. But white pine really does occupy that range of sites. So many of the sites it's at now could be suitable in the future. So overall, a moderately low vulnerability. It's really important, though, to bring these regional impacts to the site level. And there's an example on the right-hand side of my screen about how that occurs. And a good example also is just thinking about a red pine stand that could be more diverse and perhaps occupying a more mesic site. It might not fit that definition of a standard red pine stand that we sort of rated for vulnerability in the earlier slides. And in order to bring these broader impacts to site level and incorporate climate change into planning, NIAX has developed this forest adaptation resources document. And really it includes more than just looking at vulnerabilities. It includes an adaptation workbook with step-by-step instructions to assist land managers to develop on-the-ground climate adaptation tactics. And there's a menus of strategies and approaches for different resource areas that helps you put that into context. So the adaptation workbook process is composed of 5 steps. You bring management goals and objectives to this process. So this is intended to work with other land management processes. Then you bring in the resources that we talked about earlier in this presentation, vulnerability assessment, scientific lit, to assess the climate change vulnerabilities and the impacts. You evaluate the management goals and objectives given those vulnerabilities and impacts. And then you identify approaches and tactics, and that's where the menu comes in. And then finally, we monitor and evaluate effectiveness actions to make sure that the actions you're taking are helping you meet those management goals. This really is an adaptive management concept here, so that actions can be tweaked or goals can be changed as we see the effect that they have and the effect that climate change has. So I'm just going to display all of this. I want to talk a little bit more in detail about the menus of strategies and approaches. This is a tiered hierarchy that's thorough and comprehensive. So it really kind of runs the gamut of strategies and approaches to adapt to climate change. Strategies and approaches are a little bit higher level. Strategies are responses that consider ecological conditions and overarching management goals, whereas approaches consider site conditions and management objectives. There are a number of example tactics in the menus, but it's expected that you will generate your own, and you can use those examples kind of as a guide or as fodder for brainstorming. And these really run the gamut between resistance, resilience, and transition. The strategies and approaches do, based on that Miller 2007 document, which is really foundational for climate adaptation in land management. So this is an example of those strategies and approaches for the forest menu. There's menus for many different resource areas. And finally, demonstrations are really important in order to see how adaptation is actually occurring on the ground and can occur at the project level. So there are more than 400 projects that have used the adaptation workbook, and so many of those are online, over 170. You can go to the website and click on any of these and get more detail about those projects and about the strategies and approaches that they've used, the goals of those projects. And we're going to walk through one of those demonstrations today, and that's actually the Cloquet Forestry Center, stand 57. So Eli's very familiar with this project, probably more so than I am. So if there's any questions about this, maybe I'll divert those to Eli. And so you're all aware of the Cloquet Forestry Center, most likely established in 1909 as an experimental forest. And providing demonstrations like this is right in line with what this experimental forest offers. The stand that is a demonstration for climate adaptation. Stand 57 is a 12-acre stand. That's a northern dry mesic red pine, white pine woodland, according to the DNR classification, Minnesota DNR. And prior to treatment, the overstory was really dense, dominated by 7-year-old red pine, a little bit of jack pine, white pine, paper birch, and red maple and spruce as well. Regen was fairly limited, and hazel dominated the understory. As you can see in this photo, there's actually a fair amount of balsam fir in the understory as well. So the CFC generated or came to this project with a number of goals, and the goals listed now, and Eli can correct me if I'm wrong, but these were actually tweaked throughout the process a little bit. So really, again, this is adaptive management But these were the goals that were determined for this stand. And they really relate to increasing the vigor of the stand, adding some resilience with new species mixes, protecting against herbivory, and adding and maintaining habitat quality of the stand and keeping those sensitive plant communities. A number of climate impacts on the stands and some vulnerabilities that were identified. Again, the primary species in the stands aren't expected to have major declines in suitable habitat. Oak species may be suited to future climate conditions, so those species that they're interested in bringing in. And there could be wildfire risk as well with the ladder fuels in this stand.
Hey, Ryan.
Yeah.
Just another time check, 9:43, just a couple minutes left.
Okay, thanks, Eli. So on screen now, we see the tactics that were devised for this stand includes thinning, putting half-acre gaps in, protecting regen from herbivory, and that experimental mix of species. This is what one of those gaps looks like. This stand was harvested in 2016, and in 2020 they planted. And thinning the balsam was kind of an adaptive management step that they took to reduce those ladder fuels. And there's an example of what that looks like there. So in summary, for pine systems in the Lake States, overall, there's a moderate vulnerability to climate change. Suitable habitat's going to remain somewhat similar. Drought and fire may both favor and hinder these pine systems. And these species may be more suitable for different sites within our lake states. Diversity in species, structure, and age is really important for resiliency of these forest types, and there is not a lot necessarily in red pine and jack pine inherently. And active management and consideration of site level conditions is really critical. So there's no single answer for responding to climate change. I hope today that you can take away some useful information for thinking broadly about how climate change is going to impact pine-dominated systems in the Lake States, and that you can bring some of these resources and some of this information to the planning and the projects that you're working on. And NIAX is here to help. We do consultations so that you can bring those adaptation considerations into your planning. This is our job. We provide technical assistance, so get in touch. There are also a number of online adaptation and planning practices courses that you can sign up for this winter. These are 8-week courses, and there's one session per week. You get to bring your own project to them. There's one general course and a few specific courses, like courses for carbon. So, and with that, that's the end of my presentation. Thanks everybody for letting me talk. I think I ate up all my time, so I'll take a look at the questions in the chat and see if I can answer any of those. But thanks everybody for listening, and thanks for being here.
That's awesome. Ryan, thank you very much. And I was going to suggest that you do exactly that. It's 9:46. We do need to move on to our next talk. There are a lot of really good questions over in Slido. And I tried to keep up. I think I shared most of the links that you shared with me in the chat, although I got a little bit behind early on. So folks, Ryan has shared a lot of good information. I will also add those links to our Canvas course site. But great, Ryan, thank you again for posting some replies there. And again, I encourage others that these are complex topics, and Ryan's not the only one here with some answers. So please share what you know as well. Next up, we've got Nick LaBonte. Nick, we heard from Nick and Carrie a couple of days ago on Tuesday. And today, Nick is going to be bringing us up to speed. Nick, go ahead and share your screen whenever you're ready. Nick is going to be talking with us about some recent work that he and Carrie and others, many others, have been doing related to species selection and seed stock and genetic selection for regeneration activities and related things related to the Eastern Seed Zone Forum and other kinds of things. There's the I Love Baby Trees thing again. It looks great. Nick, we're seeing your slides. I saw you moving through them a moment ago. The screen looks good, and so you're on.
All right, thanks, Eli. Yeah, and I'll just acknowledge here that this is mostly Carrie's presentation material. She couldn't make it this morning, so I'll be delivering it. I work a little in this subject area too as the regional geneticist, so it's not totally out of my wheelhouse, but Carrie was more involved in the Eastern Seed Zone Forum than me, so. All right, so our goal here is to provide tools to help you make decisions about seed transfer for pines, whether you're planning to use assisted migration or not. Most of the resources on seed transfer are much older, so we've been working to synthesize old and new data and reports into a format that can be useful for nurseries and forest managers who are tasked with selecting seed sources for reforestation practices. And we think about seed sourcing as one element of the target plant concept. It is important to use the best seed source. I have to say that as a geneticist, but it is not a replacement for good silviculture, good stock types, and other limitations, of course. So there you go, source of seeds. The idea is that seed can move freely within a designated seed collection zone. That's why we put so much effort into identifying them. There are always genetic differences within a given population of trees or among the populations of trees within a region or a seed zone. But for adaptive traits, we would expect most trees within a given seed zone to have a similar set of adaptations to the local climate. Our hope is that the seed dealers and nurseries in the zone and in adjacent zones would use a common set of seed zones to describe the locations where they're getting their seed from and possibly where they're deploying it as well. Again, not a replacement for silviculture. So by adopting a common seed zone nomenclature, we can more easily label seed and once we have those labels in place, make more informed choices about where to plant it. So the Forest Service developed 2 seed collection zone systems in the relatively recent past. The generalized provisional zones, which are going to be shown on the next slide, cover the entire United States. So they cover the West and the East. And the zones developed by the Eastern Seed Zone Forum are only for the Eastern US. And I would note that the seed zone concept is a little better developed in the West with their conifer systems, just because the climate gradients there are a lot sharper and you can run into problems with moving seed around much more quickly if you're moving Douglas fir between the interior and coastal zone or things like that. So first we'll talk about the generalized provisional zones. So scientists with the Forest Service in the Western US developed this map that applied to the entire country. The layers include the ecoregions shown with boldface lines. And the colors in the background refer to a combined index of plant hardiness zones, the USDA hardiness zones we're all familiar with, which are based on minimum temperatures, and aridity, a metric of frequency and severity of drought. So if you follow the brown mustard colored seed zone across Minnesota, you can see there's some aridity changes there within the same plant hardiness zone and the same eco province. So yeah, that seed zone mostly corresponds to aridity. It overlaps a couple of similar ecological provinces. This map was set up for maximum flexibility so that managers could make decisions based on the factors that they feel are the most important for their area and for the species that they're working with. In the East, we noticed that the provisional seed zones were not being adopted. So we, and I say that as Carrie, I wasn't working for the Forest Service when this summit took place, was called the Eastern Seed Zone Forum, which held a summit in 2018 with the purpose to develop the layers that could underpin the map. In the end, they decided on a county-based seed zone system for the Eastern US. Counties are really useful in the East for partitioning the land base because they're relatively uniform in size and also relatively small in size. I know that doesn't apply to a couple of the counties you have up there in northeastern Minnesota, but most of the eastern US, they're pretty small. And because everybody kind of knows where they are, whether you're a private seed collecting contractor, or forester, a land manager, the counties are kind of a language that everybody can speak, and boundaries that are easily accessible to everybody, unlike some of the ecological zones or other ways of partitioning the land base. So seed collectors are often reluctant to provide more detailed information than a county on origin because they don't really want to reveal their secret spots for collecting a certain species. So the seed zone forum chose 2 layers for their map, the plant hardiness zones and the Bailey's eco-provinces, which are more commonly used in the East than the system that was used to develop the provisional seed zones. So first they snapped the hardiness zones and the eco-provinces to county lines, so kind of approximating them to follow the boundaries of political counties, and then overlaid them to find common polygons. And later on, some adjustments were made to make the map more usable and to remove some of the granularity or sort of weird stuff on the map that was confusing to people. I know, for example, they sought input from the previous Region 9 geneticist, Paul Barang, on whether the Eastern seed zones made sense. You can see that some of the zones cover a pretty substantial distance east to west. So they recommend using 2-letter state abbreviation and number to describe seed origin. You know, maybe like if you look at zone 52, that kind of dark purple one in Illinois, Missouri, and Iowa, maybe it goes all the way from Indiana to Nebraska. So maybe, you know, if you're growing seed in Illinois, you would want to label it as Illinois 52, and maybe you wouldn't want to accept Nebraska 52 seed at your nursery. And the purpose of that would be to avoid mixing seed from distant places. So just to reflect how people generally think about moving seed in the real world. And this map shows an inset of seed collection zones for the lake states. All the maps and a list of the seed zones by county with hardiness zone and eco-province information can be downloaded from the website easternseedzones.com, which I believe is linked on the slide there. And we can post that in the chat too, hopefully, and you can also look at some earlier versions of the zones and the provisional zones just to see what's going on in your area. So seed zones are only a mid-level descriptor of the source. It might be helpful to include additional, more specific information about the origin of the seed, including the county, latitude and longitude, or other information that might be valued by your agency. So they don't have to be the only source information you include on your seed lots. You can always get more detailed. So how can these be used? Here's an example with Wood County, right in the middle of Wisconsin. The green zone, WI22, is the local seed zone. Zone 23 to the east is a warmer zone, in part because of an influence from the Great Lakes that moderates winter temperatures. Zone 8 in blue is colder. Zone 9 is a similar hardiness zone. You could collect seed from WI22 or WI9, but WI22 is probably safer because you're likely to get seed from more southerly areas, which is desirable for climate change. And if you're looking at doing assisted migration, WI23 would be the zone to target for seed. It's slightly warmer, and that would put your collection zones in south central Wisconsin and a little bit of Illinois and Iowa as well. You'll notice that the provisional seed zones for the same point are pretty similar to what we saw with the Eastern Seed Zone Forum seed zones. It's because both systems rely on plant hardiness zones and ecological province. The Seed Zone Forum didn't include aridity or moisture because the gradients in the East are not as sharp as they are in the West. So zones in the light blue color are warmer, and seed for this adjacent warmer zone could be used for assisted migration. If you want to find a bespoke climate analog for a longer period of time in the future for a specific land base that you manage, or double check the guesses from the Eastern Seed Zone Forum on assisted migration, it would be recommended that you try the seed lot selection tool, which is free and relatively easy to use, and also developed by Forest Service scientists, I would note. So this is the homepage where you would drop a pin on your planting site, select a climate change scenario, and run the tool to see some potential good areas to collect climate adapted seed to plant at your planting site in a given time window. Oops, a little too far. This is one model run for Wood County, Wisconsin again. The objective was to find climate adapted seed lots. So the seed lot climate was set to 1961 to 1990. That's just an approximation of when the trees you would be collecting seed from started growing or started to reach maturity. So the planting site climate was set at 2041 to 2070. And depending on how aggressive you want to be with assisted migration or changing your seed source, you could consider that, the time you're planting, or a time window that covers most of when the trees will be actually growing at the site. So if you were planting them now, that would be 2041 to 2070. You'll notice that the highlighted area is pretty similar to the adjacent seed zone in the Eastern Seed Zone Forum map that we showed previously, which I'll just dial back to that. There you go. They're all based on the same numbers, so that makes sense. Now, just one note for the Forest Service folks here is that the seed lot selection tool was used to make Region 9 seed sourcing guidelines that were tailored to each national forest and the old Forest Service seed collection zones for the national forests in our 2019 Eastern Region Tree Seed Guidebook. Here's an example of seed lot selection tool output for part of the Chequamegon National Forest and the resulting future climate adaptation seed zones that we have designated for that forest. It can be very difficult to figure out the best seed sources for future climate change because we don't want to move seed so far in one generation that we end up with seedlings that are maladapted to the planting site. Many provenance trials were established and published for tree improvement purposes, but not for climate change adaptation purposes. So many of these studies are being revisited and reevaluated as tools to address climate change. So if you have a provenance trial that planted some more southern seed sources in a northern planting site, you can use that information to kind of guess how well adapted to the planting site those southern seed sources might be, or how far you can go before they become maladapted. Many studies report on gains or losses based on tree height, but that can be deceiving because trees that are not phenologically in sync with their new environment likely die off before 5 or 10-year tree heights are measured. That's why it's really great when we can get long-term provenance trials with 30 or 40 years of data, which we had for some of the red pine provenance trials I referenced in the pine presentation. So we do need to keep phenology in mind as we consider transfer decisions. We are developing an agricultural handbook that will contain seed transfer guidelines based on an extensive literature search. And we really did a dragnet of all the tree science literature to find every genetic study on these species and every provenance trial for all the major tree taxa that are planted in the East. Chapters for each species are planned to be published in the Tree Planters Notes publication, which is published by Ringer, then revised and combined into the handbook. I encourage you to visit the Climate Change Atlas, which has information on habitat suitability for over 100 tree species. Putting in another plug for the Tree Atlas there this morning. It does not have seed transfer guidelines or information on genetics, but it does have a lot of other good information. And you can see from the timeline here that some of these have already been published. The only one of these that I actually wrote is the red pine one. So if you want to read more about red pine, you can check tree planters notes in spring 2022. So each species report will cover the same set of topic areas about genetic considerations for seed transfer, some cone and seed trait information to help you plan collections if you're doing that, along with information on insects and diseases, maximum transfer distance, and range expansion potential. Now, we'll take a little bit of a deeper dive into the 3 pines that are the theme of this symposium. So of our native pines, jack pine is the most sensitive to seed transfer. Seed sources originating 70 to 140 miles south had higher growth rates than local sources in the provenance trials that we could find for jack pine. However, transfer distances of greater than 100 miles are generally not recommended. Once you get too far over 100, you start to get maladaptation, and definitely avoid transferring northern sources southward. The southern populations of jack pine are a little unique genetically, and moving more northern sources into those areas generally leads to maladaptation, or at the very least, relatively poor growth. And just as a case study, one reason to be cautious about moving jack pine seed in Minnesota is pine oak gall rust, which occurs southwest of a purple line right there. It seems that southerly range edge jack pine may have some natural resistance to pine oak gall rust because they grow around a lot of oaks, but northern populations don't. In the Minnesota Tree Improvement Cooperative second generation jack pine population in Crow Wing County, sources from Northeast Minnesota were far more susceptible to the endemic gall rust in Crow Wing County than sources that were originated from locales close to the planting site. As the climate changes and oak migrates northward, either artificially or naturally, then we might see this line shift further north, but we do not know. That is a bit of an unknown at this point. There we go. All right, for Eastern white pine, local sources or sources from Point South are best. Although white pine has high genetic variation, but it's more smoothed out than jack pine, and it's less sensitive to seed transfer. In the mid latitudes of white pine's geographic range, seed sources do a lot of mixing, and there aren't any clear winners. So again, you have a little more latitude with moving seed on white pine. The 2021 paper here by Pedler is based on tree heights at provenances, but it might overlook phenological differences that could impact survival or reproductive success. The recommendations are likely a little bit too far in terms of their maximum seed transfer distance, especially for range edge populations. So yeah, 9 degrees C of mean average temperature is pretty substantial seed transfer there. But even some of these older recommendations, 5 to 7 degrees of latitude, that's pretty substantial as well. Again, I would, based on some molecular genetics, that the Western Great Lakes has kind of a unique white pine lineage. So from a conservation genetic standpoint, it would be good to stay within sort of the Minnesota, Wisconsin, Upper Peninsula area for this species. So for red pine, genetic variation is a lot lower than in other conifers, just because of an accident in its biogeographical history where it experienced a really dramatic population bottleneck once, or possibly more than once, that caused it to lose most of its genetic diversity and become a self-pollinating, partly self-pollinating species, as opposed to an obligate outcrosser like the other pines. So at the provenance trial in Minnesota, some sources stood out as having relatively slow growth. Those were the sources from the farthest away from the planting site in Minnesota, New Brunswick in Canada, the Northwest Range Limit in Manitoba and far northwestern Ontario. Sources with the fastest growth in that trial originated in southern Michigan, which has also been found in a couple other red pine provenance trials in other areas. So the species tolerates long distance transfers. Seed sources are a little bit less important than for other pines, but I definitely wouldn't go back to the old red pine seed sourcing arrangement where it was plant whatever seed you could get wherever you're planting it, which led to a lot of main seed sources getting planted in a lot of areas where they shouldn't have been planted, just because in the CCC era, that was a relatively easy place to get red pine seed. So wouldn't go back to that, but it is a little bit less sensitive to seed transfer than the other pines. So populations of species along their range edges may have unique or different attributes that make them more sensitive to seed transfer. We see this clearly with jack pine, less so with white pine, and not much at all with red pine. Although we'll see now that we are making an effort to collect some true range edge populations of red pine, we will see if those perform a little better in our Oconto River seed orchard red pine plantings. So jack pine is the most sensitive to transfer, white pine is intermediate, and red pine is on the insensitive end of the scale. Seed collectors should still inform the nursery or seed dealer the county of origin for the seed they collect. The nursery will mix it with other sources in that seed zone. At least that's how it should work. If you're doing assisted migration, combine local seed sources with sources from a warmer seed zone. And you can use the seed lot selection tool to find areas to target for collection that are a good match as a climate analog for your planting site. Most importantly, include seed sourcing in your reforestation planning and share those plans with nurseries and seed collectors. And if you are part of the National Forest System with your regional geneticist, plan to develop seed orchards that you establish to make it easier to collect climate adapted seed in the future, saving on travel time, or designate seed collection areas, natural origin stands that are relatively easy to collect seed from to ensure that you have a stable seed supply in the future. So yeah, one thing to remember with adapting to climate change and these new seed sourcing arrangements is advanced planning can help you out a lot. So if you are establishing seed production areas or orchard type plantings now, that seed will be paid dividends in the future 10 to 20 years down the road, if not immediately. So, all right, I believe that is the end of this presentation. So I don't know how much time we have for questions, Eli.
We do have a few minutes. Nick, thank you for the talk. There are a couple of questions. I was just looking at those. I'm going to need to get myself ready here to to share. There's that. The questions, excuse me, that we're seeing now are for, excuse me, for Ryan. But here's one, Nick, and I wonder if I can make this, if I can improve the resolution here. Nick, using the seed source selection tool, have issues with allowing seed across state lines been an issue, even if it makes assisted migration sense?
Huh. I would say that there's a bit of a logistical issue if you're dealing with collecting seed in an area that you aren't familiar with, or, you know, working with an agency, like a DNR in a different state that you're not familiar with to collect the seed. I don't think there's legal issues for very many species. And, you know, I don't think there's a lot of restrictions on moving tree seed based on transmitting disease within the lake states. So yeah, I wouldn't say it's a political issue. It's mostly a logistical issue.
Okay. Next, looking at the tree atlas maps in the climate change model, How can these be improved by effectively moving seed sources? Are the projections in the model already looking at using assisted migration?
That is a great question. And I would answer it by saying that I don't think the tree atlas takes genetics into account at all. So I think it is looking at the general suite of adaptations that a species has, which for red pine, because it doesn't have very much genetic variation, that's probably pretty accurate. But no, it's not taking genetics or assisted migration into account. So I think assisted migration could help you if your area, like if you're planting jack pine and your area is becoming less suitable for jack pine based on the tree atlas, then trying to find a better, more climate adapted seed source based on a climate change model would give you a better chance of keeping jack pine in that area that's projected to become less suitable, if that makes sense.
Great. And Nick, we're going to do one more question before we go to our break at 10:15.
Sure.
This is from Matt, way up on the North Shore, Grand Portage. For smaller agencies and consultants, how do you recommend getting a hold of seedlings from other seed zones? A lot of commercial nurseries don't necessarily have options from other seed zones.
Yeah, that is a really good question. And I wish Carrie were here to answer it because she's more of an expert in the state and private nursery world than I am. If you have a nursery that you work with, like a smaller nursery, they might be willing to grow seed lots that you provide them. If you had the resources to collect seed, that's a way I could see doing it. I don't have a great answer to that.
This would be a great one for folks to reply to if others have had any success or have ideas or things that they've found that might help someone in a situation like this. I know that there are small scale efforts here in Minnesota looking at creative ways to produce planting stock for regeneration activities based on southern seed zones. But yeah, if others have found good sources, that would be great to have you share those. All right, speaking of sharing, I'm going to stop sharing this screen. It's time for our break. Let me just confirm our timing here so I don't say something that's wrong. We have a 20-minute break. We didn't have much break time yesterday, but we're gonna have 20 minutes now. We'll resume at 10:35, which is exactly 20 minutes from now. At that time, we'll hear from Brian Palick. And this might be a good time if you are, I hope you'll get up and move around and clear your head a little bit. But during our breakout sessions, as we said earlier, we're going to have you return to the questions that you and your group developed earlier in the week. I'll put that link in the chat in case you want to check in on that now too. Enjoy your break. See you in 20 minutes.